All right, so has anyone got started with the homework assignment? No? Okay. Sort of. Okay, very good. Okay, that's better than no, I haven't gotten started yet. All right.
I doubt it.
So what we'll do today is to take a look at the homework assignment, but instead of answering your questions, instead of doing your homework assignment, what I'll do is I can implement certain subroutines and certain type of constructs that will be similar or close to what you have to do, and just so that you can kind of borrow some of the ideas and reapply those in your homework assignment. And that's what we'll do today, is to deal with some of the kind of tricky aspects of your homework assignments. And let's see, I think it's 0507 10. Oops, no. CD. All right, so your homework assignment is in one single folder. I still have not created the homework assignment yet, the assignment itself, but the file is already uploaded, as of last class. You go to topic 10, it's bst.tar, the .gz part for some reason is not showing. But you download that file, and then you use the typical command, tar xcvf, the file name, and we'll create a subfolder called bst. And in BST, you will find symlinks to the .c files. And then what you need to do is to replace each of those files, the ones that are symlinks, replace those one at a time with the assembly version of the same code. So I'm going to show you exactly what I mean by that. On Tuesday, I did exactly that. I created the BST subfolder. And then inside the BST subfolder, if you have color coded turning on, you can see the ones that are kind of like light blue color. Those are the ones that are symlinks. So the .c, except for main and node gen or node include generator, all the other ones that start with BST something .c, those are the ones that you have to convert into assembly language. So you can do it one at a time, or you can try to do all at the same time. Not highly recommended. Just do one at a time, and make sure the program works pretty much the same way, and then move on to the next one. So what we'll do today is first we'll take a look at all of these files. So I can use a vim, in this case bst*.c. So that will basically make sure that I cover all of those files. And it chose to start with bst destroy. This is the subroutine. So we are not really talking about complicated subroutines in this case, in this homework assignment. If you know how to do one statement, okay, the next statement is fairly simple. The conditional statement is, well, okay, let's start with the conditional statement. What do you think the conditional statement is really checking? When do we get into the conditional statement in this case?
If there's an existing p-root.
Okay, so p-root has to point to a non-null value. Okay? In other words, we are not checking whether p-root itself is null. We're checking whether p-root is pointing to a pointer that is null. Is that okay? Okay? There's a big difference. Okay? In other words, if I was to check whether p-root itself is null or not null, then this would do it. Okay, this will check whether p-root is null, and if p-root is not null, then we'll go into the subroutine. Once I add an asterisk before p-root, then it's checking whether what p-root points to, which is a pointer to, is null or not. Because you have to look at the actual type of the parameter. P-root is a pointer to a structure. Okay, so when you dereference p-root once, you still have a pointer, and that pointer can be either null, which means, okay, I don't have anything to do, because when p-root is pointing to a null pointer, it means that the tree is empty and there's nothing to do. But if p-root is pointing to a non-null pointer, then you have at least one node in the tree, and then you have to delete that tree. Are we doing okay so far? Sort of? Okay. So are we okay with the condition of the conditional statement part? All right. Now, in this case, in the C code, when you dereference proot, it becomes a pointer to a struct node. That's the type checking part. But in assembly language programming, there's no such thing as type checking. Okay, so you have to be extra careful when you do dereferencing, because you have to make sure that what you're dereferencing is actually the right thing, the right type. If you look at line 8 and line 9, if you know how to deal with line 8, line 9 is just a copy. You just change one of the numbers from PL to PG, and that's it. So now the question is, how do we get to, well, how do you read that thing to begin with? In other words, what are we passing on line 8 to BST destroy itself? Obviously, this is recursive, but what are we actually passing? How do we specify? How do we calculate that particular thing? Okay, we are trying to take the address of a member of a structure that is pointed to by a pointer that itself is pointed to by proot. Okay. And let me tie my shoelace so I don't fall on my face. And then we'll try to use the document camera again. We'll give it one try. If it doesn't work, then we'll just reboot and not use it again in this class. But I was able to use it, earlier this morning in another classroom that has been using this, for a while. So it might be the computer here that's causing problems. So we'll go ahead and plug it in. Make sure the thing is still working. Yep, it's still working. And it's still working. So I'm just going to be paranoid here and just check it once in a while. And we'll use this software to. All right, so it's working today. I have no idea why sometimes it doesn't work and other times it works. This is good. Change the resolution to 1028 and it's still working. Except the screen is it's too big, it won't fit into this particular screen, so I have to kind of resize it and make sure that it fits. Let's go. Getting closer. And just fix that part here. All right, excellent. All right. So now all I need is a piece of paper. And a pen. Okay. All right, so this is let's go back to our text window here and go back to the editor. And what I'm doing here is I'm just copying the one thing that we are trying to implement. So then we can try to do it step by step and figure out exactly in the picture what does it look like, and then from there we can try to figure out in code what are we going to do to get to it. All right, so we have this little thing here. This is the parameter to push on the stack so that we can call the subroutine itself. So the question now is, how do we deal with something like this? Okay, when you look at this whole thing, it looks kind of complicated. There are a lot of levels of parentheses. There's a dereference, and then there's an address of, and then there's also a pointer thing, which is the accessing a member of a structure that is pointed to by a pointer. Okay, so the way to do this is not. First of all, do not panic. Okay, first of all, do not just look at this whole thing and go like, "Oh man, this is so complicated. I don't want to deal with it." Okay, you just have to do it one step at a time. So how do you deal with an equation or an expression that has a lot of parentheses? Do you start from the outside or do you start from the inside?
Inside.
You start with the inside. Very good. So in this case, the innermost portion is p-root. Okay. So what I'll do is I'm going to use a kind of pictorial representation with a p-root here. P-root, where do you think we can find p-root? In other words, how do I get to p-root itself as a parameter? What kind of addressing mode and what type of operand do we use to access p-root itself? What kind of addressing mode? Spaced addressing mode. We are using p-root as a symbolic name, and then in parentheses we put EBP because it's a parameter. It is a part of the frame of this particular invocation of the subroutine. So we know how to get to p-root. So this box here is representing 4 bytes on the stack that is a pointer itself. What is the first operation that we have to apply to p-root?
Dereference it.
Dereference because of the asterisk. Okay, so that means p-root is pointing to another 4 bytes because the whatever it's pointing at is also an address. Are we doing okay so far with this picture? First thing is to dereference, so we have a pointer pointing to another 4 byte thing. That 4 byte thing is a pointer as well. Okay, so we take care of, so far we have taken care of this portion here. So this portion maps to this portion here. Are we doing okay so far? Can everybody understand what I'm trying to map from and map to? Okay. Now that other pointer, which is just a rectangle with no name, is pointing to what? What kind of thing is it pointing to?
The node.
It's pointing to a struct node. A struct node. Okay, very good. So this thing here in return is pointing to a struct node. A struct node has, it's bigger. It has at least 3 members. The way it is defined has 3 members at this point. The first one is v, which is a integer value, 32-bit integer value. The second one, I think I use PL first and then PG. Okay, but the order is really not important because you have to make your code so that it is insensitive to the ordering of these members within the structure. Okay, so it's a structure, and that is really taking care of this part here. The last thing we have to do is to get to PL. Okay, PL is this guy here, so we have to figure out, PL, we can find it in assembly. We have to say we can find PL. If I know how to get to the beginning of a struct node, I should be able to get to the member called PL. Is that okay? So you have to somehow figure out what is the distance from the beginning of a struct node to PL as a member within a struct node. And that is the entire thing. So if you look at this whole thing, including the PL, we are specifying this part. And now I just want to take the address of that. In other words, I want to get to this pointer. Do we know how to do this? The first part is a move instruction from the stack as a parameter into a register. The second part is a dereference, so you can use a move instruction with indirect as the source and then a register as the second as the destination. The third thing we have to do is kind of a little bit more tricky because we don't want to really dereference it, because if you dereference, this step here, okay, I'm talking about this link here, we don't want to dereference it because we don't really want to access the entire structure. We only want to get the address of a particular member. After the let's see here, after the dereference, we have a pointer to point it here already. We just need to add a displacement so it points there. That is what you need to push on the stack. Are we doing okay so far with this? No, not really. Is that okay or not? I like that reaction. You're just going, maybe, maybe not. All right, okay. So now that we have this picture and it's also recorded as a part of the screen recording, we'll go ahead and write a very simple program that kind of illustrates the same thing, but it's not in the same context as this. So I'm going to quit all the way out of this, keep this terminal at this place, and then use the other one, not this one, but this one, to go to the folder for today. And we'll just go ahead and write a very simple program to illustrate, kind of how to do something like this. And I have not made a folder yet for today. And we'll just call this swap. I should call this swap member. Okay. All right. So this is a really simple thing. I have a structure that I call struct x. And inside struct x, I have two integers. The first one is int a, and the other one is int b. And then we have the usual swap subroutine. So swap does not return any value. It takes an integer pointer to the first one. So I just say this is a pointer to the first number, and then we have another pointer pointing to the second number. I'll call it pm. And then inside the swap subroutine, I have my t temporary local variable. And then we say t gets whatever pn points to. Whatever pn points to is now getting a copy of whatever pm points to. And then whatever pm points to, now we can get the value of t. I will not implement swap again. We have done that already. Okay, so this is not something that I'm going to implement in assembly. Okay, now we have our main subroutine, main, and then inside main I have struct x. We'll just call that the local variable b. Okay. And what I really want to implement is how do I swap the v dot v dot a with v dot b. And that's the thing that I want to illustrate. Okay? Can you relate this particular sample program to the homework assignment? It's not exactly the way it is specified in the homework assignment, but it's really just a change of perspective that can make the homework assignment basically the same thing as this one. Okay? All right, so let's go ahead and try to implement this in assembly. Okay, so this is the only line that I want to implement in assembly. And since this is actually written in C, I'm going to comment out this part here because it's going to be the assembly implementation of this particular code. And I will make assumptions about certain labels are already defined. In other words, I will assume that the label x, uppercase x underscore a, lowercase a, is the displacement or the offset from the beginning of a struct x to member a. And then x underscore b is the same thing, except it applies to member b. So I'm assuming those labels are already predefined because that you have to do that first with your own homework assignment. All right, so let's go ahead and try to figure out what is the address of member b of a structure, struct x, and it is a stack-based local variable b in this case. Okay. So what we'll do is I'll start with this. Okay. I know that b as a label is important, so I moved b into, let's say, EAX. Using our convention in this class, what do you think b as a label is defined? How is it defined?
You can offset from the stack to the beginning of b.
Is the offset from where EBB points to,
yeah, that's right,
to the first byte of the local variable b, which is on the stack. Yep. Okay, so that's what EAX is at this point. So I'm going to comment that. So at this point, EAX is the offset from where EBP points to the first byte of local variable b. Okay. Are we doing okay so far with this? Okay. But that's really not quite the address of the structure of V, because it's just an offset from where the register EBP points to the first byte. So how do I get to the address of the first byte of local variable V? I have to add EBP to EAX. Okay, so we add EBP to EAX. So at this point, EAX is the address of variable V. Variable V. All right. So up to this point, does it matter what V is? What if V is an integer? What if V is a unsigned long? Does it matter at this point? It doesn't matter at this point. Okay, we're just getting to the first byte of local variable V. But V can be a structure, V can be an integer, it can be an array. It doesn't really matter. But now that we know that V is a structure, and I want to get to the address of member B, what do I do at this point? I know I'm pretty close already, because I already get to the address of the entire structure. I want to get to the address of one of its members. So what do I do at this point?
And move forward to
Add the offset of B.
Add the offset of member B from the beginning of the entire structure to EAX. Okay, that's exactly what we need to do. So we have another add long instruction here, but this time I'm adding $, which is immediate, x underscore B to EAX. So at this point, the EAX is the address of member B of variable B. Any questions about this part? And, well, isn't that what we really want to push on the stack before we call swap? So at this point, the only thing left to do is really to push EAX on the stack. Push EAX on the stack. Okay, we'll make it nicer. Push swap. There we go. Do I need to go through, do I have to explain the other parameter? It's the same thing, right? Okay. So I'm going to stop here, but this is a little bit different from the code that you have to write, okay? So we want to find out how are these two, how is this different from what you have to do in your homework assignment?
The layer of pointers.
Well, in your homework assignment, you have a pointer to a structure. Whereas in here, you have a variable that is actually local, so you're not dealing with any pointers whatsoever. Okay? But that's the only difference. Any questions about this part? No questions? Okay. All right. I'll give you a second test program, a second sample program. When you combine the first with the second one, then you will have quote-unquote the solution to the entire homework assignment. Okay. So the second one, I would call that indirect. And in this case, we have we'll use the same swap. No, I'm not going to do that. Trying to make this so that this one is going to attach to the first one, but if you combine the techniques, then you get the actual solution to a part of your homework assignment. So let's see here. Void. Okay, we'll just call this F, and we're dealing with integer. Pointer to an integer, we'll just call this PPI, which stands for pointer to an integer. Okay. So in this case, if I want to actually change whatever is the actual integer to 0, what do I need to do? Equals 0. And then in the main subroutine, so I'm just going to give you the entire thing so you know how it is all set up. So in the main subroutine, I start with an integer, okay, that is going to actually store some value. So I'll call this v. And then I'll have a pointer to v. So this is actually a pointer to an integer. And just to make this more complete, we have a pointer to a value, which I call PVV. Okay. So in order to get all of these initialized, the first thing I have to do is to say, oh, PV is going to be an address of an integer, and that will fit that requirement. Are we doing okay so far with this code? So far, okay. But PPV is a pointer to an integer, so to initialize that, it is the address of PV, like so. When I invoke the subroutine, I need to pass a pointer to an integer to subroutine f. So when I invoke the subroutine, PPV is the one that I need to pass in order to get v initialized to a 0. Can everybody kind of see how this is relating to at least a part of your homework assignment? So now there are a few questions. Okay, I'm going to demonstrate the assembly code to various portions of this particular example program. I will start with PV. Okay, I will start with this one here. Let me turn on the line number so I can refer to the line numbers. I'll start with line 13. Okay, how do I implement line 13 in assembly? Assuming the labels are all defined correctly already. In other words, P, PV, and PVV are already defined, as displacement from where EVP points to the various local variables in this case. So I'm assuming those labels are already predefined. How should I get started with this one? We are dealing with the address of V. So, well, I'll start with something that is incorrect, and you guys can tell me why it is not right. Okay? What if I do something like this? I know I cannot have two memory operands in one single instruction, so I'm going to use EAX as a temporary register in order to move that thing into PPV, EVP. So tell me, is this, not PPV, just PV. There we go. Okay, so tell me whether this is doing the same thing as the C code on line 13, and if not, what is it doing exactly? Okay, first question first. Is it implementing what line 13 as a C code, C statement is doing? It's not. Why is it not doing that? What is it doing actually instead? Yes?
It's moving the actual value of V.
It's moving the value of V, which is an integer, into a pointer. Okay? So that means, this incorrect version of the code is actually doing this. This is actually doing the following. It's actually doing a PV equals V in C. But you can say, but that's not possible because C will never let you mix the types together, right? The right-hand side in this case has a type of int. The left-hand side has a type of pointer to an int. That can never happen. But you know what? C leaves you a rope long enough to shoot yourself in the foot a few times. So you can always do something like this to make the compiler happy. Okay, but it accomplishes the same incorrect implementation. So if you look at line 15 to line 16 at this point, it is wrong because it is actually implementing the C code that is in the comment section on line 16. That's not what we want. How do we fix it so that we can actually move the address of local variable V into PV?
Move the offset
$V.
Yep. Okay, so the correct solution in this case is we have to move the displacement itself by itself into EAX first. And then you add to it whatever EVP is. EVP is a pointer. And when you add EVP to EAX in this case, then right now, EAX is the address of local variable V. Well, that's exactly what I want. So now I can just move EAX into PV, which is a local variable, and that will finish it. So are we doing okay so far at this point? Because I really want everybody to understand how lines 15 to 16 are completely different from lines 20 to line 22. What about, since I changed the line numbers a little bit, what about line 24 right now? Do you think line 24 requires its own demonstration, or do you think it is the same thing as something we have already talked about? There's no need to talk about it.
It's the same thing.
It's the same thing, okay? Because we're taking the address of PV. The fact that PV itself is a pointer has no relevancy whatsoever, okay? Because we're still taking the address of a local variable and store that into another pointer that is also a local variable. So the fact that your PV itself is a pointer has no bearing in the implementation in this case. All right? So I'm just going to leave the line 24 to yourself, to you, so that you can actually do it. Okay, now we'll shift our attention to line 3, which seems to be kind of strange, but it's not really that strange. So now we shift our attention to line 3. If I were to implement this in assembly, what would I do? Well, first of all, I'll do something incorrect first, and then you guys can tell me why is this incorrect. So I'll do the simplest thing possible, and then I'll ask you, first of all, is this the correct implementation of the C code on line 3? No. What is it actually doing in this case?
Setting 0 as the address.
This is the same as PPI gets 0. That's what it's implementing, which is not what we want. Okay. Do you think this will cause a segmentation fault right now?
Probably.
No, it does not. It cannot cause a segmentation fault because let's see whether why it may or may not cause a segmentation fault. A segmentation fault is caused by, most likely, that you are trying to access a location that is not supposed to be written to. Okay? And that has to do with the second operand. So the first operand can be whatever. It's the second operand that can cause problems. So in this case, when you look at the second operand, assuming the stack is set up correctly, the frame pointer PEVP is set up correctly, what is the second operand specifying? Where am I actually putting that 0 into?
Into the pointer. What it's pointing to.
And PPI is a what?
It's a pointer to an integer.
Okay, but that's the type. But in addition to the type, what is it? Is it a local variable? Is it a parameter? Or is it a global variable?
It's a parameter.
Is a parameter, okay? Is it okay for me to override a parameter?
Yeah.
Would it, well, first, okay, I should rephrase it. Does it cause a segmentation fault? If I overwrite a parameter that is on the stack passed to me, will that by itself cause a segmentation fault?
No.
No. So this is wrong, but it won't cause a segmentation fault. But it won't accomplish what line 3 in C is supposed to accomplish. Okay. How do I fix this? So what we'll do, I'm going to leave this one here. So let's move PPI EBP into EAX, okay? Because I see a dereference. Every time you see an asterisk in C, it is a dereference. So this time I'm a little bit smarter, and I say, well, what about this? I do one dereference. What is it doing in this case? If you combine the effects of line 7 and line 8, what is it doing? Well, first of all, is it doing what we are supposed to?
Nope.
And if not, what exactly is it doing? If you are to write the C version of this code on line 7 and line 8, what do you think it would look like? Okay. Now, we know that we are starting with PPI because line 7 is copying the parameter PPI into a register EAX, which is eventually used as a part of a second operand. So we know the left-hand side of the assignment is going to be PPI something.
It's essentially going asterisk PPI is equal to 0.
Yep, that's exactly what it's doing. But that's closer to what we want to do, but not quite exactly what we want to do. Okay. So the third one is going to say, well, I guess we have to do it one more time. So we'll move PPI, EBP into EAX. And then what we'll do is we'll dereference EAX into EAX. So if I want to comment each line, EAX is the parameter PPI after line 10 executes. After line 11 executes, EAX is whatever PPI points to. Okay? Tell me what is the type of whatever PPI points to. Is it an integer or is it a pointer to an integer? It's a pointer to an integer. Okay? So in the third instruction, then I'll put 0 into whatever EAX points to. So the C implementation of this is going to be exactly what we want, because we have two dereferencing in this case. Okay. Are we doing okay so far? So can everybody kind of relate what you're seeing in this particular sample program combined with whatever you saw earlier in the previous sample program, and combine those to answer that one single question about BST destroy? I don't see any relevancy, because in in the BST destroy, that statement or that expression has one dereference and then has a pointer thingy. So how is this related to that? It doesn't seem to connect at all. Let's take a look. Let's take a look at the third sample program. The third sample program is going to be, I don't even know how to call that. Let's call it, I'll just call it member. All right, so we'll have a structure again. We'll call it struct X. And we're going to give it like two members, int I, int j. Doesn't even matter what these are. Do a void pointer here, and we have something kind of similar to what we had in the other one. So we have a struct X pointer to a pointer, and this is what PPX is. Okay, it's a pointer to a struct X. So what I want to do is to basically just illustrate two expressions that have exactly the same meaning. The first expression is, I have a local variable t here. Okay, this makes it kind of a little bit more meaningful. So if I want type checking to work, okay, everything to match up, this definitely won't work, because ppx is a pointer to a struct x, and t on the other hand is an integer. So this won't work. Okay. What if I put a dereference first? Okay. Would that work?
Nope.
What is the right-hand side specifying? What is the type of the right-hand side of the assignment?
Pointer to struct.
It is now a pointer to a struct x. Okay, nothing is matching still. Okay. Now here's the fun part. What about this one? What is the type of the right-hand side?
Pointer to a struct.
No, the entire thing, the entire right-hand side of line 11 at this point. What is the type of the right-hand side?
Should be a struct X.
It is a struct X. Okay, but it won't. But the type checking will fail because t is an integer, and now on the right-hand side we have an entire structure. You cannot assign an entire structure to an integer. But that one is an easy one to fix, because I know within the structure we have two members that are integers. So if I just specify one of them, then everything should be fine. Okay, as far as type checking is concerned, this will work. Okay, are we doing okay so far? But how is this related to BST destroy? Because we never saw anything like this in BST destroy. We saw a dereference and then we have a pointer. How is this related?
Because if you get rid of that first dereference, or on the outer parenthesis set, get rid of the dot, you can make it the dash greater than.
Well, Yep. Well, that's kind of what it is. The reason is these two statements are identical. In terms of the meaning, line 11 and line 12 are exactly the same thing. It's just that one is quote unquote a shorthand of the other one. Why do you think line 11 is not common? Why don't people use line 11, the form that we see on line 11?
More keystrokes?
It's because of the parentheses. Okay. Now you can remove the parentheses a little bit because you can basically say, asterisk, asterisk, ppx, then you can remove one level of parentheses, and it will still be the same thing as line 12. Okay.
It's because you got to remember the order of operations when you're talking about the dereference and the period. And with the dash greater than notation, you don't have to think of the order of operation.
Well, the dash greater than is really a combination of an asterisk, which is the dereference, and a dot, which is to access a particular member of.
Right, but then you don't have to worry about having parentheses to get the dereference of the right.
Right, you get rid of one level of the dereference. Right, correct. Okay. So is that relating to your homework assignment? Okay, because what you need to do is to look at line 12, or something that looks like line 12, and then you say, oh, that really is the same thing as line 11. Okay. So can we implement line? Okay, let me give you another one before we go any further. Okay. So at this point, the only thing that is remaining is, do we know how to do this? I think I'm missing one. Is it like that? Okay. So the expression that I have on line 13, this is not valid C syntax because this expression is all by itself. But if that is what I want to push on the stack, can we do that now? It is the address of a member that is from a structure. The structure is pointed to by a pointer, and that pointer is in return pointed to by another pointer. Okay. So once again, we get back to the picture that I drew a little bit earlier. Okay, remember this picture? So in this particular case, in the program that we just looked at here, we have ppx. Okay, so we have ppx itself. It's a parameter that is on the stack. It is a pointer. But what it points to is another pointer. This other pointer points to a structure. In this case, the structure has two particular members. One is I and one is J. The expression doesn't want to access I or J. It wants to come up with the address of one of the members. I think it's I in this case. So you have to kind of think about, how do we get to the address and not the value of that particular address. So we doing okay so far? Because I don't want to, give you the entire solution because I want you to kind of think about it and, come up with your own implementation. But I want to give you enough tools and make sure that you understand the C code itself, and also how to map your C code to basic assembly assembly instructions. These are the pieces. You have to kind of look at each piece and see how it fits in your homework assignment, and then you have to kind of put all the pieces together, to make it work. Any questions about this? No questions? Okay. How can you, implement a program that is similar to what we have in the homework assignment, but a lot simpler without any recursion, so that you can check whether you understand the concepts correctly or not? Sorry? A small program. Now here is my suggestion, okay? So that means, this is something that you don't have to turn in, but I would highly recommend people who look at this and go like, but I don't know how to do that. Well, let's do this one program, okay? So this is, I call this warm app.c, okay? Struct X, same thing, int I, int j, or I should have said int I comma j, but okay, either way. All right. We have the swap subroutine, okay? And the reason that my obsession with the swap subroutine will be apparent later on, okay? So we have int t, oops, t gets whatever PA points to, whatever PA points to gets whatever PB points to, and then whatever PB points to gets whatever PA used to point to, which is now in T. So that's the swap subroutine. And then we have another subroutine here. We'll just call this F, because it really doesn't serve any particular purpose other than, to illustrate the concept that we're dealing with here. So this one deals with a structure to a pointer. Okay, it deals with a pointer to a struct X. So PPX in this case. And all F is going to do is to call swap. But the way it is calling swap or the the expression is exactly what you need in your homework assignment. Okay, because it is taking the address of something and then the address of something. The first one is going to be the address of member I, and then the second is the other one, PX goes to J. And then we have another subroutine here, just as one intermediate step to this. So this is PX. And this is going to invoke F using the address of PX. And then we have main. Main starts with an actual structure X. We'll just call it V here. And it's going to invoke G with the address of V. And then we do a 0. And let's make it so that you can actually check whether your subroutine is working or not. So all we have to do is to put two specific values into member I and member J. So I make I start with the value of 5, and make J start with the value of 17. And after you call G, you want to use the debugger to check the values of member I and member G, because if your implementation is correct, then I and J, as members, will have, the values exchanged. Okay, but it's good verification because if you look at the call to swap, the structure of those expressions that you have to push to swap are exactly the same nature as what you need to deal with in BST destroy. Okay, and that's why this particular program is significant. Is because it maps exactly to what you need to do in BST destroy. But it is a much simpler program to debug, okay? Because all it really wants to do is to exchange the values of member I and member J of the V structure in the main subroutine. And you know exactly what it's supposed to do. It has no recursion. It has no conditional statements whatsoever. It works. If it doesn't work, then you have to figure out why it's not working. But it's relatively easy to figure out why this one is not working. The purpose of subroutine G and subroutine F is really there to reinforce your concept, the concept of how do you take the address of something, whether that something is a local variable or whether it's a parameter, it doesn't matter. How do you take the address of something and then push it on the stack so you can call another subroutine? So I would use this as a warm-up, because it's a very simple program to implement, and yet at the same time, you have to exercise pretty much all of the same skills that you need in order to get your homework assignment done. Are we okay with this one?
Could you, something that would help me just for clarification, could you write a make file real quick that we can file this with an assembly file for that function?
Okay, well, first of all, I'm going to test it to make sure that it does work, right? Otherwise, it would be pretty embarrassing. Okay, so we do GDB, warm up, and we want to put a breakpoint. We'll put one on line 30, and then we'll put one on line 32. Program, print, local variable v, which is a structure. We have 5 and 17. Continue execution, print v again. Now we have 17 and 5. So this way, I double check and make sure that the C code is working the way it's supposed to, and then we can restructure this, and copy, make use of a makefile. Okay, so let's quit, and okay, I'm just trying to figure out, how I want to do this. Let's do a warm up subfolder up. Okay, of course not. And make it warm up. cp warm up.c to the folder, and the folder. I'll just be lazy and copy one of the make files from earlier. And we'll copy the make file from and just adapt that one. And you won't need this one because they're you do. So we have X include generation, and the assembly file is, I think swap is the one that you want to implement. No, it's F, right? F is the one that you want to implement. So F here, the executable is more up. That's it, except for this one. So we have x.inc, x.inc, that should be it. All right. So the way to do this one, this is another thing that you can also do. I'm trying to figure out, how, to make it so that you can just go ahead and implement F. We can just do it like this. Just comment out the C implementation of F, and then just have a prototype of F here to replace that. And then we can go to F.S. I'll even go ahead and include the header file here for you guys, so I can make sure that the makefile is working correctly. .global F and .text F colon turn. Okay, it's complaining about no rule to make target xgen keys.
Since you're not implementing the structure in assembly, do you really need that?
Well, no, you are. You will need X include generator. It's just that source file is not even there.
Okay.
So I have to give you a shell of this source file.
Okay.
That's all we need to do.
I mean, yeah, I know.
And I forgot, I did not make X I did make an X header file, so I will do that too. This, and instead we just say count include x.h. Oops. All right, x.inc, no such file or directory. Working now. So this is not a real homework assignment. I'll put the tar file, onto Moodle, but it's a good warm-up, exercise for the actual thing, because once you figure this one out, the actual homework assignment is kind of, redundant, because this will take care of the most difficult part of the homework assignment. All right. So clean again. Back to the parent folder. Create the tar file. And drag it into Moodle, and we are all set. And remember, this one is not a homework assignment. You don't have to do this one, but I think it will be beneficial to get through this one first, and then you'll start on bst.tar. 2 days. There we go. So now it's online, and it's a big clue. Okay, this is a big clue to get your homework assignment done, along with the other 2 sample programs. Yep.
What is the exam due?
It's due on the same day as your final exam, which is the second last day of instruction. Okay, so you have a little bit more than a week. I think you have close to 2 weeks, maybe 12 days to get it done. The difficult part is to remember to do it. All right. So are there any questions about the homework assignment? No, not at this point. Okay. So we haven't really finished looking at all the code in the homework assignments, so we'll go back and resume that. This one is done. We'll move on to the next one. This is BST insert, inserting a node into a tree. So if you look at the source code of this one here, do you see anything here that is, well, I don't know how to do this. Okay, let's go through this line by line and try to figure out, okay, what does it mean in C, and can we do that in assembly? Okay. We start with line 6. What is line 6 doing? How do I get into, what is the condition that will get me to execute line 8? In other words, what does it mean when not p root points to is true?
P root is null.
What p root points to is not null. Okay, so you have to remember, that one dereference. So before you check it to 0, you have to dereference it first. Okay. So that's what line 6 is, and then we have line 8. Line 8 looks kind of complicated. How do we do typecasting in assembly language? Because the typecasting part is open paren, struct, node, asterisk, close paren. That's a typecast operator in C. How do we do that in assembly? We never talk about that.
Just $sign whatever the structure is.
No, we don't do it at all. There is no type in assembly language programming, and therefore there's no typecasting either. So all the typecasting that you have to do in C is only there to convince the C compiler that you know what you're doing. The assembler automatically makes the assumption that you know what you're doing, so you don't have to convince it whatsoever. Are we doing okay so far? So the typecasting is, there's no assembly code corresponding to the typecasting. What about malloc? We never really talked about how to use the heap in assembly language. How do we deal with that malloc thing? Well, malloc is a function call. Have we talked about function calls? You call malloc just like you call any subroutine. Okay? If the name is malloc, then you call malloc. Okay? The linker will figure out how to do it, just like printf in the previous homework assignment. What about that size of struct node thing? We never really talked about that either. In your generator, the include file generator, you should generate node underscore size and have that label to be defined to be exactly the size of a structure of a struct node. Okay, so that's how you know the size of a struct node, and that's it. Okay, the most tricky part is you're not updating p-root with the right-hand side. You're updating whatever p-root points to the right-hand side. So when you store, you have to do one dereference in order to store to the right place. All right. How about line 9? Now, line 9 can be very easy to implement, depending on whether you threw away the return value of malloc after line 8. Okay, if you keep the pointer that is returned by malloc, because malloc is returning a pointer, and the pointer is stored in EAX just like an integer. So EAX, has the pointer to the entire structure, and you can reuse that pointer in line 9, 10, and 11. Okay. But what you're doing is you're not changing directly what that pointer points to, because that pointer points to an entire structure. What you want to do is to change only a certain part of the entire structure. Which memory operand do you think would be useful in this case? You start with a pointer that is pointing to almost exactly what you want to change, except oh, you know what, B is a little bit off from the beginning, and PL it has another offset, and PG has another offset. So which address info do you think would be useful? Based, exactly. What would be your base register in this case? B. EBP. No, we don't want EBP in this case. Because EBP is not pointing to where the structure is pointing to. Which register is pointing to the structure itself? EAX. So you have to use EAX as the base pointer, okay, as a base register. Okay. Any other questions about lines 9, 10, and 11? Let me double check the recorder is still running, because I think this may be one of those lectures where the recorder, okay, everything is still running, making sure it's recording from the right channel. It is. Okay, so we still have everything. Good. I'm just paranoid because we have lost the recorder a few times already. Okay, so we are done with the then portion of the conditional statement. In other words, from line 6 to line 11, that's done. On line 15, do we know how to deal with both sides of the comparison on line 15? One side is easy, it's really just a parameter. The other side is whatever p-root points to, okay? But p-root points to another pointer, and that pointer points to a structure. We just want to access member B of that structure. So it's something that we have already talked about a few times. You just have to kind of follow the links and make sure that you know how to do it. And then we are now moving on to line 17 and line 21. Have we seen anything like that already at this point? Line 17 and line 21, especially the first parameter to the subroutine? That's exactly what we saw in BST destroy. It's exactly the same thing. Except in this case, the subroutine requires 2 parameters instead of 1. Other than that, it's really the kind of same kind of structure. So, are there any questions about this particular file, BST insert? I think if you get BST destroy done, this one can be done relatively quickly. Any questions before we move on to the next one? Go ahead.
So when malloc returns EAX address of whatever, then I just from that point on, I just use EAX for line 9, and 10.
Right. Yeah, you just have to be careful when you do the dereference of p-root for the left-hand side. You use some register other than EAX. So it doesn't override. Or you can push it first, and then you can do other things to make sure that you preserve that particular register.
So, do you have access to the heap in this one?
Not directly, but you still have access to malloc and free. So you're still using the heap just like you would, use the heap in C and C++. The new and delete are a little bit different because you have to mess around with the namespace of the class. But malloc and free, It works exactly the same way as in C. Any other questions about this particular subroutine? There are no questions about this one. We'll move on to the next one. BST print. BST print is actually a little bit easier than the other two because you look at line 6. Line 6 has no dereferencing whatsoever. It really is just checking whether the parameter itself is 0 or not. Okay? If the parameter is non-zero, then you go ahead and go to line 8, 9, and 10. If it is 0, then there's nothing to do. You're all done. Okay? So in this case, you are just testing whether the parameter p node itself is 0 or not. We look at line 8. Line 8 is trying to push the pointer, which is the member PL of a node is a pointer. We're pushing that pointer onto the stack and then call BST print again. Okay, I think that's considerably less complicated than the other two subroutines that we have seen so far. Any questions about this one? We know how to do the printf already, so that's really should not be an issue. Yeah.
If you were going to do a jump by comparing 0, would that be considered sign or unsigned?
It works. There's no signedness when you're comparing to 0 and see whether it is 0 or not. Now, if you're trying to compare to see whether it's greater than 0 or less than 0, then you still have to use either JL or JB. Well, there's no JB in this case because nothing can be less than 0 in the unsigned interpretation. But when you are just checking for equality, then JZ is JZ, JNZ is JNZ. The sign does not is not important because you're just comparing, you're matching 0 in this case, whether it's exactly the same or not. You're not saying you're not trying to determine which one is larger. So in this case, there's no choice. You don't really have to choose. Should I use JB or should I use JL? Because those are not the flags that you're looking for. Okay. Right. So BST print is fairly easy, and now we have BST read, the only one that is not recursive. And by the way, are recursive subroutines harder to debug than non-recursive subroutines? Why do you think they're more complicated to debug?
Part of all of the logic and where things are going.
But the recursive call is no different from a non-recursive call. You set up the parameters exactly the same way, you call the subroutine the same way, and then you clean up the stack the same way too. So just kind of keep that in mind. The only part of recursion that makes it kind of complicated is if you don't check the conditions correctly, you can end up with an endless recursion. So it will just keep going and going and going. But you can have an infinite loop too if you're not dealing with recursion. If you're using iterations or loops, you can still end up in an infinite loop. And it's no more difficult to deal with that compared to an infinite loop because you really just need to check the condition itself. Okay, so this is BST read. BST read is the only one that does not have recursion. But when you look at this code here, I think for the most part it's a lot easier because there are no taking the address of, there are no dereferencing. The only part that you have to take the address of is on line 11. Because on line 11, when you call scanf, you have to push the address of I on the stack first, and then the address of the literal string %d, which specifies that I want to feed a signed integer into whatever the pointer points to. That's the only time you have to take the address of something. Do we know how to take the address of a local variable I? Okay. So the rest of this, there are no tricky things. There are no tricky things around here in this one. Even though it calls BST insert, we are passing the entire p root to BST insert. We're not taking the address of anything. We're not doing any dereferencing, and I don't even care what p root points to. Okay, it can point to anything. I'm just passing it along. Okay. So are there any questions about BST read? Questions about BST read? So that means, BST read is also a good candidate as one of the first subroutines to implement because it really is one of the easier ones to implement. And that's it. Those are all the subroutines that you have to implement in assembly. And there's a lot of symmetry in this program compared to your previous one, factoring. This one has a lot of symmetry. In other words, a lot of times if you figure out how to do one statement, the next one or the one after next is just copy and paste, and all you have to do is to remember to change the member from PG to PL or vice versa. Okay, but otherwise, they're really the same kind of code. Are there any questions at this point about your final and bonus homework assignment?
Oh, okay, that's what I was going to ask.
I just answered your question. Yes, it is bonus, which means if you have a perfect score already with all your homework assignments, this is on top of the 20%. And I'll even make this like a high point value, so it will account for like 5% of your final grade. Yep.
So it's extra credit.
It is extra credit. Yep. So now, combining this with a perfect score of the final exam, people can get 45%, just out of those two. Yep.
When is the final exam? The syllabus says May 15, 2012.
It's the 21st.
Yeah, I forgot to update the syllabus. So it is
The 21st.
the 21st, and the time is from 8 p.m. to 10 p.m.
What day is that? Monday or Wednesday?
Huh?
Is that Monday or Wednesday?
No, it has to be a Tuesday or Thursday.
Oh no, sorry. Yeah.
Yeah, I think it's a Tuesday.
Said it was 8 to 10.
8 p.m. to 10 p.m. And we'll do it
Yeah.
on paper, in this classroom.
Tuesday, May 21st.
Okay, Tuesday, May 21st. There you go. Are there any other questions? What if I tell you I just had a hard drive failure and all the notes that I captured is gone?
I already took it down.
I think, if you can basically say, well, that really sucks, but, I think I understand most of the concepts, that would be a good sign, okay? Because, the video is good, okay? But it still relies on you guys, to actually kind of at least understand most of the material during the class. You may not remember all the details, okay? But that's okay. That's what the recording is for. But as far as the concepts are concerned, you really need to kind of get it as I talk about it. So are there any questions about the homework assignment? Any particular construct that you want me to explain? I can only give you pieces of a puzzle at a time because I don't want to give you like one chunk of code where you can just copy and paste, change a few names, and that's your homework assignment. That kind of defeats the whole purpose of the homework assignment. But I can give you like chunks, and then you have to combine the different chunks into your homework.
What kind of bribes do you take?
I don't think you guys need to do that. Okay, so I think you guys can figure this one out. Are you talking about the bonus homework, the extra credit homework assignments?
This time.
In general.
There might be a Pepsi in a bag of cheese.
Yes.
This have all or nothing, or can you get partial projects?
I will grade this one the same way as I grade, the other, practical homework assignments. So I will give it test cases, and then your program has to work, in all of the test cases. And I can tell you all the tricky test cases already. Okay, with this one, the tricky test case 1 will be in an empty file. What if there's nothing? Okay, so let me just run the program with nothing and see what it does. Okay, all right. This is still the C version. Okay, so we can just go ahead and run the main program. So the way that you normally run this program is you give it, a kind of particular sequence of numbers like that. Press Control D to end, this sequence, and it will print out, those numbers, but in a sorted order. Okay. So my recommendation, if you're testing your program and you really want to make your program easier to debug, is to give it, like a standardized, test input. So you can just say, test.in is my standard test. And you can just start with something like this, just 3 numbers. Then you can have /main, redirect from test.in. So this way you can just reuse the same test case over and over again, and make sure that your assembly code or the implementation that includes your assembly code will do exactly the same thing. The second thing is to explain what is one of the trickier test cases. Is you call main, okay, you invoke main, and then you right away you press Control D. It should not crash, okay? It should not give you a segmentation fault, because in this case, what is happening is BST read is reading nothing. So you still have an empty binary search tree by the time BST read is done. So when you call BST destroy, it has an empty tree to destroy. But that code already accommodates for an empty tree, because when you track down an entire tree, eventually every single leaf will lead to an empty tree. So that part has to work. And this is one little test case to make sure that you can handle that part. When you are running or testing your program, I would suggest you to give it a single value and then press Control D, just so that it does not have to do much recursion. It will still have to do a little bit of recursion, but not very deep. So that makes it easier to debug the program. The other tip, go ahead.
What's the command Control D do?
Control D is not a command. Instead, it's kind of like backspace or tab. It's a special sequence that means something to the code mode of the console. It really just means end a file, but it only applies when you're reading from the console. So Control D by itself inside a text file is just Control D. It has no special meaning when it is inside the file, but when you're using the console and interacting with the program, then Control D means, okay, I'm done with the input file. This is the end of standard in. That's basically what it means.
Okay.
So when you're debugging your program, the other thing you can also do, or the other thing that I recommend you to do, is to run main as a C program. And then you give it a test file with only one single value. And then what you do is you track down how it does the recursion. So when you are implementing your assembly code, you know what it is supposed to do. Okay? How many times is it going to invoke itself? What kind of values should I see as it invokes the subroutine and stuff like that. So that means you can see on one side, okay, this is the C implementation, this is my implementation in assembly. They should mirror, okay, the structure of the calling and the returning. That should be the same. Okay, you're just changing the implementation from one language to another language. All right. So go ahead.
Are you going to put this up as a regular on 7 on the
Yes. So you will have the typical instructions of the use bar, ACDF to press it. Okay, so I'm going to the lab. If you guys want to get started with the homework assignment tonight, I will be at the lab, and I highly recommend you to get started with this one earlier because it can be a little bit sticky.
It is so relieving to know that this is extra credit. It just takes a load off my mind.
But it's also nice to know that.
Considering